Okay, Chapter 10, Hypothesis Testing. So in Chapter 9, we mentioned that there's two types of inferential statistics, estimation and hypothesis testing. So we already discussed the procedures for estimating the population proportion and the population mean. So now we're going to talk about hypothesis testing. A hypothesis is a statement regarding a characteristic of one or more populations. We're going to look at hypotheses plural, hypothesis singular. We're going to look at hypotheses regarding a single population parameter. Okay, so example. In 2008, 62% of American adults regularly volunteered their time for charity work. A researcher believes that this percentage is different today. So this is a statement regarding a population proportion, right? The percent of the population. According to a study published in March 2006, the mean length of a phone call on a cellular telephone was 3.25 minutes. A researcher believes that the mean length of a call has increased since then. This is a statement involving the population mean. Using an old manufacturing process, the standard deviation of the amount of wine put in a bottle was 0.23 ounces. With new equipment, the quality control manager believes the standard deviation has decreased. So now we have a statement about the population standard deviation, but notice they're all just regarding a single parameter, right? 3 different examples, each involving a single parameter. Okay, so we're going to test these types of statements using sample data because it's usually impossible or impractical, too expensive, to gain access to the entire population. So the procedure we use to test such statements is called hypothesis testing. Okay? Remember, if population data are available, there's no need to do any inferential statistics. We don't have to infer if we have data on the entire population. We can just analyze it and state what's happening with the population. All right, hypothesis testing is a procedure based on sample evidence and probability used to test statements regarding a characteristic of one or more populations, and once again we said in our case of a population. Here's the steps in hypothesis testing. Okay, 1, make a statement regarding the nature of the population, okay, like those statements we mentioned before. Collect evidence to test the statement. Analyze the data to assess the plausibility of the statement. So, because we use sample data to test hypotheses, we cannot state with 100% certainty that the statement is true. We can only determine whether the sample data support the statement or not. Okay? In fact, because the statement can be either true or false, hypothesis testing is based on 2 types of hypotheses: the null hypothesis and the alternative hypothesis. The null hypothesis, which we're going to denote by H sub naught sub 0, is a statement to be tested. The null hypothesis is a statement of no change, no effect, no difference, and is assumed true unless evidence indicates otherwise. The alternative hypothesis, H sub 1, is the statement that we're trying to find evidence to support. So null hypothesis, the original statement, right? An alternative hypothesis, the one that we're testing. All right, in this chapter, there are 3 ways to set up the null and alternative hypotheses. Okay, equal versus not equal hypothesis, which is a 2-tailed test. So you're saying that the null hypothesis is equal to some value, but the alternative hypothesis is saying it's not equal to that value. Equal versus less than, which we've got the null hypothesis is always equal to our value, But this time the alternative hypothesis is saying it's less than that value. Okay, equal versus greater than. Our null hypothesis, once again, we're saying it's equal to a particular value, but our alternative hypothesis is saying we suspect it's bigger than that value. Okay, so two-tailed test and a left-tailed and a right-tailed. The null hypothesis is a statement of status quo or no difference and always contains a statement of equality. Always look at the null hypothesis. It always has the equal sign. The null hypothesis is assumed to be true until we have evidence to the contrary. Okay? We are seeking evidence that supports the statement in the alternative hypothesis. Okay? Left and right-tailed tests are referred to as one-tailed versus the two-tailed. Okay, notice that in the left-tailed test, the direction of the inequality points to the left. And in the right-tailed test, the direction of the inequality points to the right. That should be obvious because if you think about a number line and your parameter is assumed to be equal some value at the current, under the current conditions, and you think it's more than that, more than your particular value would be to the right. Less than your particular value would be to the left. Okay? All right, example. For each of the following claims, determine the null and alternative hypotheses. State whether the test is two-tailed, left-tailed, or right-tailed. All right, so first, in 2008, 62% of American adults regularly volunteered their time for charity work. A researcher believes that this percentage is different today. So it's asked me to state my two hypotheses. So I've got a null hypothesis and an alternative hypothesis. Okay, so the hypothesis deals with a population proportion because it's just the percent of the population. Right? So I'm going to use P. Your null hypothesis is always where you currently stand with your data. Right? But if this researcher believes that this percentage is different, right, and it doesn't say more than or less than, just not 0.62, then that's our alternative hypothesis. Okay, which means it's a two-tailed test. It can be more than or less than. Okay, according to a study published in March 2006, the mean length of a phone call on a cellular telephone was 3¼ minutes. A researcher believes that the mean length of a call has increased since then. So my null hypothesis, this time we're talking about the population mean. It's always what it is believed to be equal. My alternative hypothesis, the researcher is trying to show that the mean length has increased. So, I don't know why I put an equal there. So, is more than, right, 3.25. In other words, right-tailed, because he thinks it's larger than or on the right-hand side, right, pointing to the right. Using an old manufacturing process, the standard deviation of the amount of wine put in a bottle was 0.23 ounces. With new equipment, the quality control manager believes the standard deviation has decreased. So what is your null hypothesis? Okay, first of all, we got to figure out what kind of parameter we have. Standard deviation. All right? And you're right, the null hypothesis is always the one that's equal to the current value. What's your alternative hypothesis? Yeah, that the standard deviation has gotten smaller than 0.23. Okay, less variability. You've gotten better equipment. So We're hoping that it made that variability smaller. Right-tailed or left-tailed or two-tailed test? You got it, left-tailed. Okay? Okay. Sample data is used to decide whether or not to reject the statement in the null hypothesis. Because this decision is based on sample information, there is the possibility of making an incorrect decision. In fact, there are 4 possible outcomes from hypothesis testing. Okay, 1, you can reject the null hypothesis when the alternative hypothesis is indeed true, and you would have a correct decision. It's what you should have done. 2, you do not reject the null hypothesis when the null hypothesis is indeed true, and you've made another correct decision. But you could reject the null hypothesis when the null hypothesis is actually true. So you would have made an incorrect decision. This type of error is called a type 1 error. Or you could not reject the null hypothesis when you should have, when the alternative hypothesis is actually true, but you didn't reject the null hypothesis. That's another incorrect decision, and that's called a type 2 error. So in other words, when you're testing a hypothesis, there's always the possibility that your conclusion will be wrong. To make matters worse, you're not going to know whether you're wrong or not. So we have some tools to help manage these incorrect conclusions. All right, one more time. Type 1 error is you reject the null hypothesis and you should not have. Type 2 error, you do not reject the null hypothesis and you should have. Okay, so here's an example. For each of the following claims, explain what it would mean to make a type 1 error and what would it mean to make a type 2 error. All right, first one. In 2008, 62% of American adults regularly volunteered their time for charity work. A researcher believes that this percentage is different today. Okay, so let's get our hypotheses. All right, this is just a percentage of the population, so I don't know why I wrote a mu there. I haven't even figured out what I need yet. So I need a p for the population proportion, and it's always that it's equal to. Okay, now my alternative hypotheses, it's just, he believes it's different. In other words, not equal to, it's different. Not necessarily larger or greater, just not this. Okay, so a type 1 error is made if the researcher concludes that this is not 0.62, right? In other words, type 1 is when you reject the null hypotheses and you should not have. A type 2 error is made if he does not reject it and he should have, right? When it's actually different. So type 1 error means that the researcher says, right, that he is going to reject this. Type 2 error is when he does not reject it. According to a study published in March 2006, the mean length of a phone call on a cell phone was 3¼ minutes. A researcher believes that the mean length of a call has increased since then. Now we're talking about mean. Okay, the null hypothesis is always equal. Alternative hypotheses are new suspicion. And this time he says it's increased. He believes. He's trying to prove that it's increased. So a type 1 error occurs if the researcher concludes that the mean is actually more than 3.25 when it's really still 3.25. In other words, he rejects the null hypotheses and he should not have. That's type 1. A type 2 error occurs if the researcher fails to reject it, right? When in fact it was more and he should have. He failed to reject it, but he should have. Okay, we want to be really careful about our wording here. There's going to be a caution coming up later, but notice I'm just saying he fails to reject it or does not. No, that's the same thing. Let me reword that. He either does not reject the null hypotheses or he does reject the null hypotheses, right? So type 1 error is when he rejects the null hypotheses and he should not have. A type 2 error is when he does not reject it and he should have. Okay, remember when we studied confidence intervals? We learned that we never know whether a confidence interval contains the unknown parameter. We only know the likelihood that a confidence interval contains the parameter. Similarly, we never know whether the conclusion of a hypothesis test is correct. But just like we placed a level of confidence in the construction of a confidence interval, we can assign probabilities to making a type 1 or type 2 error when testing our hypotheses. So here's the common notation. We're going to let alpha be a type 1 error, beta be a type 2 error. So alpha and beta, again, the Greek alphabet, and at least these two are easy. It's like A, B, alpha, beta, right? So alpha for 1, beta for 2 to help us remember that. Okay, so alpha is going to be the probability that we made a type 1 error. Remember what a type 1 error means. We rejected the null hypotheses when it's really true, when we should not have. A type 2 error means we did not reject the null hypotheses and we should have, because the alternative is actually true. Okay, the probability of making a type 1 error is chosen by the researcher before the sample is collected. The level of significance is the probability of making a type 1 error. Okay, the choice of the level of significance depends on the consequences of making that error, right? If the consequences are severe or really important, then you want to choose your level of significance to be really small. Maybe let alpha equal 0.01. In other words, 1% chance that you've made that error. However, if the consequences aren't that severe, you might choose a 0.05 or a 0.1, a 5 or 10% chance that you've made the error. Okay, so in other words, as the probability of a type 1 error increases, the probability of a type 2 error decreases, and vice versa. Okay, be careful. We never accept the null hypothesis. That's what I was talking about a little bit earlier. Because without having access to the entire population, we don't know the exact value of the parameter stated in the null hypothesis. Rather, we just say that we do not reject the null hypothesis. This is just like the court system. Think of it like that. We never declare a defendant innocent. All we can say is that they're not guilty. There's a huge difference being told you're not guilty, right? Very different than being told you're innocent. Okay? Doesn't really mean that you didn't do it. It's just, hey, we can't prove that you did it, so we're going to say you're not guilty. Okay? Sample evidence can never prove the null hypothesis to be true. By not rejecting the null hypothesis, we are just saying that the evidence indicates it could be true, right? But never say we have proven the null hypothesis is true. All we're going to say is, well, I can't reject it, so I'm going to accept it. I'm going to conclude it, but I haven't proven that, right? Okay. According to a study published in March 2006, the mean length of a phone call on a cell phone was 3.25 minutes. A researcher believes that the mean length of a call has increased since then. Suppose the sample evidence indicates that the null hypothesis should be rejected. State the wording of the conclusion. Okay, this is what we want to be careful about, our wording. Okay, the statement in the alternative hypothesis, let's write them down first so that we can just think about what that means. So our null hypothesis, we're talking about, where are we at? A mean equals 3.25. Our alternative hypothesis then is believes the mean length has increased. Okay, so the sample evidence indicates that the null hypothesis should be rejected. Okay, state the wording of the conclusion. Okay. Because the null hypothesis is rejected, now here's your wording. There is sufficient evidence to conclude that the mean length of a call is actually more than 3.25. There is sufficient evidence to conclude that the mean length of a call is actually more than 3.25. Okay, here we have the same hypothesis, it's just a different question. Right? Suppose the sample evidence indicates that the null hypothesis should not be rejected. State the wording of the conclusion. Okay. There is not sufficient evidence to say that the mean length of the call is more than 3.25. I'm not going to say I conclude that the mean length is 3.25. I'm going to say there's not sufficient evidence to conclude that it's more than 3.25. Up here, I'm going to say there is sufficient evidence to conclude it actually is more than 3.25, and I'm going to reject the fact that it is 3.25. Down here, I don't know why I haven't checked that. I cannot reject the null hypothesis. All that means is there's not sufficient evidence to say it's more than 3.25. I don't know if it's still 3.25 or not. I couldn't prove it's not. Okay. Last one. According to the National Association of Home Builders, the mean price of an existing single-family home in 2013 was $245,700. A real estate broker believes that existing home prices in her neighborhood are lower. Determine the null and alternative hypotheses. Okay, we're talking about the mean. So the null hypothesis is that it's equal to the $245,700. So the alternative hypothesis would be what about the mean? She believes that the prices in her neighborhood are lower. Explain what it would mean to make a type 1 error. Okay, so a type 1 error is when you reject the null hypotheses when you should not. So I'm not going to write it all out in words because it's so hard to write on this. But that would mean that the evidence leads the real estate broker to conclude that the mean price really is lower when it's not. Okay? Type 1 means you reject the null hypotheses when you should not have. Explain what it would mean to make a type 2 error. The evidence leads the broker to conclude that the mean price is not lower when it really is. Okay? In other words, you don't reject the null hypothesis, and you should have. Okay, hopefully that makes sense. Let me know if you need anything.